Welcome to the Velocity Lab. The lab is mostly set up for you already. You should see a ramp, and your LabQuest and your motion detector should be hooked to each other. The motion detector should be sitting at the top of the ramp, and your Hall's carriage, the blue car, should be somewhere nearby with an index card already taped to it. Just make sure that the motion detector is set up like this so it makes an L shape with this part of it, whoops, not that part of it, this part of it facing at a right angle. And that's so that when the sound is emitted, it'll come out and hit the reflective surface of that card and then bounce back to the motion detector. And the length of time it takes for the sound to come back to the motion detector is how it determines what position something is in. It'll make a little sound like click, 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 and that's how it will actually detect where the objects are. Double check that the motion detector setting that is right here, this little switch, make sure it's on the cart position, not on the basketball or person position. And once you've done that, you're pretty much ready to start collecting data. You just have to set up your LabQuest. This is the LabQuest, and if it's not on this position when you get started, you want to make sure that, whoops, you want to make sure that you click this button, that's the home button, and that'll get you here. And hopefully it's already set up for the right rate and duration. But if it's not on 5 samples per second and 3 seconds duration, then you can just touch either one of those blue boxes and a screen will come up where you can enter new information. This number here tells you how far away your motion detector is from the white card of your cart. Until you put the cart there, it'll be reading whatever's the nearest object is. So it'll probably read something like this. And that's about the distance that most objects are from the motion detector before you put the cart on there. Okay, so once you have that set up, it's time to start collecting data. To do that, you're actually going to click this button right here. But when you hit that button, you're going to want to be totally ready to send your cart down the ramp. So to get your cart ready to go down the ramp, you're going to put that cart at the 1.5 meter line, and that line will be marked off for you somewhere. It's probably further away than that, but from the motion detector. That line marks where the point is from the bottom of the ramp to 1.5 meters. So it's a release point of 1.5 meters, meaning that the cart from that position, if you release the cart from that position, it'll travel 1.5 meters to the end of your ramp. Excuse me, so the distance between here and here, however, is what's going to be reading on your motion detector when you start. And you want to record that number because that distance is really important. It should be around 0.30 something meters, about 1/3 of a meter. And that distance is your starting position. In your data table, you'll notice that the first thing you're going to record is the release point. So the release point for this first test is 1.5 meters, but the distance from the motion detector is whatever the reading is on the digital display of your LabQuest. And like I say, it'll probably be around 0.300 meters. What you're going to do is you're going to put your finger where the black line here is, and that's going to hold your cart in place. The front wheel should just be touching the tape that marks off the 1.5 meter mark. Put your finger there, and then you're going to have another person hit that little green button that I mentioned before. When that person hits that little green button, you're going to hear click, 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 and then a stop, and then click, click, click again. You're waiting for the clicks to start again. So here's what it sounds like. Click, 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 click. That little break is what you're listening for, because as soon as it ends, you're going to release the cart. The first few clicks are to warn you, hey, the motion detector is getting ready to take a reading. The little break tells you, okay, getting ready to start. And as soon as you hear that first click, it means the motion detector is actually recording data. So you want to release right when you hear it. When you pull your finger back, make sure that you pull back without knocking your cart out of the way. So best way to do it is to move your finger straight back, not this way. Don't move your finger this way because you might actually drag the wheels of the cart with you when you pull your finger back. So you want to make a nice clean release. You're going to do that. The cart's going to roll down the ramp. In the 3 seconds or so that it takes to reach the bottom, your motion detector will take 5 readings per second about the position of the cart, and that will all come out on the screen of the LabQuest. Keep in mind when you repeat this experiment, you're going to need to start again at that 0.300 meters position. If you don't, then you're not going to be keeping things constant in your trials. So make sure when you repeat the experiment that you put the cart at exactly that distance from the motion detector again. After you're finished with your first test, what you're going to do is you're going to get a graph like this on the LabQuest. And if you've hooked your LabQuest to your iPad, it'll show up on your iPad as well. So what you're going to do is you're going to check that that little blue graph at the bottom is a nice rounded hill. It should not look something like this. It shouldn't look like, whoa, sorry, always doing that when I mean to grab the pen. Okay, here we go. You don't want it to look like that, right? It shouldn't be like all bumpy and lumpy. If it is, that's a problem, and you can't use that data. You're going to discard it as an outlier, not even write it down. But if your data is nice and smooth, like the blue line shows, then what you're going to do is you're going to put your finger on this little circle and drag it over to the top of your hill. And that way it'll tell you the exact velocity at that point, because this is what we're measuring. We're measuring how the fastest speed that our cart got up to on its way down the ramp. You're going to record that number in your data table for trial 1 for the 1.5 meter distance. So you're going to write all three numbers, 0.541 meters per second. Then you're going to repeat the experiment. And when you repeat the experiment, you're going to check to make sure that after 3 trials of the experiment that you have precise data. Precise data will have a range no bigger than 0.300 meters per second. So if you take your highest number and subtract your lowest number, it can't be any further apart than that. If it is, that means you're going to need to do the experiment again until you get 3 data points that are within 0.300 of each other. Once you have those 3 data points that are that close together or that precise, you can circle them and take an average. Sometimes it happens that all 3 trials in a row are within 0.300, and sometimes it'll take you, twice as many tries to get data that's that precise. The key thing is to only average the data that fits within that range. Anything beyond that range, we're going to consider an outlier. You can write down those numbers, but don't include them in finding your average. And remember to circle the 3 numbers that you do use to find your average. Finally, after you have your data table filled in, it's time to make a graph. Any graph of data should be set up like this. On the x-axis, you're going to put your independent variable and the units you measured it in. And on your y-axis, you're going to put your dependent variable and the units you measured that in. Now, you have to figure out what your independent and dependent variable are for this experiment, and I'm not going to tell you because that's something you need to know. You need to be able to figure that out on your own. I might give you a hint if you're really stuck. But work on it, think about it, remember what your independent and dependent variables are, how to figure them out. So label all of that, and then up top you're going to have a title, and I like to put as my title for any graph, the effects of the independent variable. And this is where you plug in what your independent variable is on the dependent variable. And again, this is where you plug in your dependent variable. And of course, in here you're going to actually graph your data, so you'll need to create a scale here and here with actual numbers, and then you'll have 3 points. Your 3 averages will be plotted there. After you've done that, you can call me over. You should do this on a piece of loose leaf or just scrap paper. Call me over, I'll look at it, I'll let you know if you're on the right track or if you need to fix anything before you try to move it onto the computer. There's a couple different ways to graph things on the iPad, and I'll show you all those different ways when you call me over. Finally, after you're done processing the data, you're going to need to write a conclusion. So you're going to use the template that I gave you for writing the conclusion, and you're going to make sure that you address all of the bullet points in the template, so including talking about your original hypothesis. Now, these are procedures, so I'm assuming that you've already done your hypothesis as per the first tutorial that I had you watch. In the first tutorial, I asked you to make a prediction about what you thought was going to happen. And hopefully you did that, because if you didn't do that before you started the experiment, it becomes really hard to go back and figure out, well, what was I thinking before I knew what really happened? So you'll see at the very top of the velocity lab, name and period, and then prediction. What do you expect to happen to the velocity of the car as we release it from higher and higher points along the ramp? Explain your reasoning. That would be your rationale. You're going to need to include in your conclusion both your original hypothesis and your rationale for it. And then in your conclusion, you're going to tell me whether or not the data supports or rejects your hypothesis, and so on. So you need all of that information in order to do that. You should look at the rubric and make sure before you submit the lab that you have taken care of all of these things. Every spot on that rubric, each individual thing on the rubric, counts for 5 points. So you have to make sure that your data is rounded to one decimal place and includes units where needed. You should make sure that your document is formatted in an attractive way. All your work is reasonably proofread. Your graph is well planned and organized and shows craftsmanship. You need to show the work for finding your averages. There's space for you to do that on the document. You can do it by hand as well, in like GoodNotes or something, and then import it if you're having difficulty typing it. You have to make sure that your graph includes all the needed labels and keys. Your conclusion paragraph should address each bullet on the template checklist. And your conclusion should show a respect for the evidence. So it should really be based on what you saw happen in your actual data. And your graph should show an understanding of how to make and interpret a graph from the data. And your prediction should be logical and make sense. And probably apply Occam's razor too. Okay, keep all of that in mind, and when you're ready to submit your lab, you go right ahead and submit it through the classroom. See you guys in class.